Hello, students. Welcome to lesson 2, the basics of logic. And I like to start my lectures with some quotes. And so this first one is from Proverbs 14 and 15. It says, "A simple person believes every word he hears, and a clever one understands the need for truth." And I know that's why you're here in this class, because you are clever and you understand the need for truth. The second quote is from Charles Peirce, and it says, "The object of reason is to find out from the consideration of what we already know something else which we do not know." And so that's what we're going to learn this week. And let's get a few definitions out of the way. As I said in the last lesson, you can use the definition of logic, which was given in lesson 1. You can use the definitions that's given in this lecture, or the one that's in the textbook on any quizzes or exams. So the definition of logic says, logic investigates and classifies the structure of statements and arguments, both through the study of formal systems of inferences and through the study of arguments in natural language. Another definition is, logic is the art and science of reasoning. It's a very short one. Logic is the art and science of reasoning. So reasoning has laws, right? So all reasoning happens within the boundaries of laws, like how we exist, things that have weight exist within the laws of gravity. And so there are laws of reasoning. So one way that we describe the laws of reasoning is the laws of thought. So the laws of thought are fundamental rules upon which rational discourse is based. The laws of thought are as follows. 1, the law of non-contradiction, the law of identity, the law of excluded middle, and the law of rational discourse. As we go through these, you're going to see that these all are different aspects of the same thing. It's telling you how we must deal with propositions. So let's start with the law of identity. I am starting to introduce you to writing things symbolically by writing the law of non-contradiction as A is not non-A. It's not accurate, but I want you to just get used to that. You know, we're going to get more and more into symbols as we get in. So that's not how you would really write A is not non-A, but we have to start somewhere. So what does that mean? A is not non-A. It means no two contradictory statements can be true at the same time and in the same relationship. In logic and disciplines related to logic, all the words are important, right? So no two contradictory statements can be true at the same time and in the same relationship. So another way of saying that is nothing can be both true and not true at the same time in the same place, you know? An example that I've been using for a few years because I think it's provocative. Why is it provocative? You'll see after. Is God is omniscient. So God being omniscient is one of his incommunicable attributes. In lesson 1, we talked about one of his communicable attributes. But this is one of God's incommunicable attributes. He cannot give us the ability to be omniscient, but he is. So what does it mean to be omniscient? Being omniscient means that God has perfect knowledge, that he has instantaneous knowledge, that he cannot grow in knowledge, that he cannot lose knowledge. He just has all knowledge at the same time. It's very difficult for us to conceptualize because human beings, we grow in knowledge, right? So the first statement says God is omniscient. And the second statement says that God remembered. And I'm saying to you that these two statements, when held together, cannot be true at the same time in the same relationship. So I know that already you are annoyed, you're mad, you're upset because you are calling to mind several scriptures that says that God remembered or that he forgot. So you're saying, oh, what kind of teacher is this? But remember, the law of non-contradiction says two statements cannot be true, contradictory statements cannot be true at the same time and in the same relationship. So are there scriptures that says God remembered? Yes, but it is used not in the same way and in the same relationship as the statements that talk about God being omniscient, and the Bible is not contradicting itself. Excuse me. So what's going on here? These two statements do not contradict. So yeah, let's continue and talk about what's going on with those two statements, if they are indeed violating the law of contradiction, if they are held together. Well, what's happening is that scriptures that talk about God forgetting or remembering are using anthropomorphic language. What do I mean? It means that these scriptures are using words that relate to how human beings understand or how human beings exist, so that we, human beings, can understand some aspect or some emotion or some perspective of God. These passages are not intending to teach you that God is forgetting stuff or God is remembering stuff. Because if he is forgetting stuff and he is remembering stuff, he is in fact not omniscient. So this is not a course on hermeneutics, but your hermeneutics teacher will clarify that a little bit more. So let's move on to the second law, which is the law of identity. A is A. So what that means, A is A means a thing is what it is. So going back, and it is different from everything else. So going back to our example of God being omniscient, this law would say God is omniscient and omniscient is what he is. He is what he is, right? And a thing is what it is, and it is different from anything else. A man is a man, and a man is not a dog. You know, the law of identity, a thing is what it is. Now we have all kinds of controversial things that are happening where we have to reaffirm the law of identity because a man is a man and a woman is a woman and a human being is not a unicorn. The law of identity, a thing is what it is. The third law is the law of excluded middle. The law of excluded middle is zooming further into how propositions must work and still be rational, right? So this law says either A or none A. What does it mean? It means that everything must be or not be. Another way to look at that is A well-formed logical statement is true or it is false. There is no hole in the middle. Either it is true that you're a man or false that you're a man. There is no middle ground, is what this law is saying. So let's look at another way of describing the law of excluded middle. Given any logical statement, P is either true or it is not true. Let's look at an example. If it is true, it is either true that the world is flat or it's false that it's flat. There is no middle ground. If you propose an argument that includes a middle ground, that argument violates the law of excluded middle. And the final one is the law of rational inference. The law of rational inference allows us to infer things immediately. And so the law of rational inference states that every conclusion reached must follow absolutely from an accepted premise. So the law of rational inference says, if A, then B. If A, then B, that's a hypothetical proposition. If I'm saying, if you obey God, then he will bless you, A implies B. So think about it. If you obey God, then he will bless you. Your obedience to God implies that you will be blessed. But you can't start from you will be blessed and infer that you have obeyed God. So read the law again. The law of rational inference states that every conclusion reached must follow from absolute reasoning based on accepted premises. One example is Mark 16:16. He that believeth and is baptized shall be saved. Now, please don't take the scripture, this text out of context. I am not proposing baptismal regeneration. It's just a text that happens to help us understand the law of rational inference. So based on the law of rational inference, Mark is saying that the person must believe and be baptized. And so rational inference will not permit the neglect of either baptism or belief in order to be saved. So don't pull any doctrine from this. I'm just telling you how the law of rational inference works, that the conclusion must be absolutely inferred from the accepted premises. So there are two types of reasoning. We have been doing a type of reasoning in the laws of thought, but we want to know the two types of reasoning. What do I mean? Whenever we're reasoning, we're doing one of these two things. What are they? We're doing inductive reasoning or deductive reasoning. So we're going to start with deductive reasoning. Another name for deductive reasoning is a priori reasoning. A priori reasoning. A priori means looking at the facts. Sorry. Deductive reasoning is used when you reason from what you know to be true in general to decide what must be true in a specific case. Another way of thinking about deductive reasoning is that you reason from general tenets to specific conclusions. This is also important because deductive reasoning yields necessary conclusions. What does that mean? It means that the conclusion is true, is necessarily true. It can't be false if the premises are true and the inferences are valid. And so that's a powerful reasoning technique if the conclusions are necessarily true, right? So let's look at an example where we're reasoning from what we know to be true in general, and then we're able to deduce specific information and draw conclusions from it. So this is the world famous Lucy. She's only famous in logic class, but still. So this is a syllogism. We haven't learned syllogism yet, but this is a syllogism. The first premise is monkeys like banana. It could be apes, but let's say monkeys. Monkeys like banana. That's general. That's a general premise. And we're going to say, for the sake of this conversation, that that's true, that all monkeys like bananas. Now, we want to know something about a specific monkey who happens to be Lucy. So we reason from the general tenets of all monkeys like bananas, and we try to figure out what's going on with Lucy. So look at the second premise. Lucy is a monkey. True. So if it is true that all monkeys like bananas, and it is true that Lucy is a monkey, the conclusion must be true that Lucy likes bananas. Do you see how that reasoning works? And if all of those premises are true and the inferences are valid, which I'm going to tell you now, I'll teach you why later, the inferences are valid, this argument is sound, it's true and valid. So that is a really powerful tool. So recap, deductive arguments reason from general to specific. It can also reason from general to general. And this kind of reasoning is what we use in philosophical and theological circles. We use it a lot in philosophical and theological circles. In logic, there are different types of, or different ways of doing deductive reasoning. But in this particular logic class, we are going to use syllogisms, like with Lucy, to understand deductive reasoning or to practice deductive reasoning. So one example that deals in the realm of theology and not monkeys is the cosmological argument for the existence of God. Now, this is a very convoluted way of writing the cosmological argument, but this is deductive reasoning. So let's read the cosmological argument. Everything that we observe in the universe is contingent. A sequence of causally related contingent things cannot be infinite. The sequence of causally dependent contingent things must be finite. Therefore, there must be a first cause in the sequence of contingent causes. And so Aquinas argues that whatever is in motion must be put in motion by another. So the conclusion is there must be a first cause in the sequence of contingent causes. The purpose of this example is to show you how deductive reasoning helps us in apologetics. The other type of reasoning is inductive reasoning. Inductive reasoning is called posteriori. Posteriori means what we know by observation, what we can know by observation. So inductive reasoning is a process of deriving reliable generalizations, keyword, generalizations from observations, so that the premises of an argument are believed to support the conclusion, but do not necessarily ensure it. Inductive reasoning yields only probable conclusions, while deductive reasoning, what we studied before, yields guaranteed conclusions. So inductive reasoning, which is the other part of this table, You see that we reason from particular to general. Why? Because you have to observe the phenomena, and then from that observation, you draw a general conclusion. And the scientific method depends on that, right? So when a scientist wants to prove a hypothesis, the only tool that the scientist has is inductive reasoning. So he observes the phenomena, and from observing particular instances of that phenomena, he comes up with a generalization. So inductive reasoning reasons from particular to general, from particular to particular, and inductive reasoning is scientific reasoning. So deductive reasoning is philosophical reasoning. Inductive reasoning is scientific reasoning. So one quick example of induction or inductive reasoning is the efforts of Charles Darwin as published in The Origin of Species. So what happened is that Charles Darwin had a hypothesis about what's going on in nature, how nature is producing new life. And so he started out to prove his hypothesis by observing. Remember, inductive reasoning, observation. So what did he observe first? He observed artificial selection of plants and animals. So artificial selection is why we have the breeds of animals and plants that we have today. I don't know if you've heard that, let's say bananas that we eat now, that's not how bananas were originally. They were small, they were not sweet, they had seeds, and the same for watermelons and different things, that they came to be what we eat now through artificial selection, right? So farmers would exchange traits to create the plant that they want. Same thing with animals, right? Where farmers would breed animals with desired traits to produce a generation of animals that have the traits that it desires. So a lot of the species of plants and animals that we see now are here by artificial selection. So Darwin observed what the farmers were doing through artificial selection, and he deduced that nature was doing this as well. He deduced that nature was making the same kind of decisions as these farmers. That was a bad induction. We'll talk about it at in some other class, because you cannot go from artificial and then your conclusion, artificial selection, right? And then your conclusion is natural selection is the same. That's an example of bad induction. But an example of good induction is coming up here. So one example of good induction is trying to understand gravity. So the law of gravity was based on observation, inductive reasoning. The observation was that every time something that had weight and mass was released, it would fall to the ground. Every time. And the conclusion was all things fall to the ground. And so that's an example of good induction. So we have come to the end of this second lesson. Hopefully you are enjoying it so far and you are learning, you're understanding everything that is being said. And I will see you in the next lecture.